Hello, everyone. Hope you're well. Today, we're going to talk about how we apply AI models in a recruitment context in a club to solve some of the challenges that the clubs are facing. My name is Jens Melvang. I'm a pro product manager for Stats Perform, and I'm joined by Joe Gallagher and Daniel Dinsdale that are working on our AI team. Now, I will go in and talk a little about the why and what is the value around these AI models and how they're applied in the club. And then Joe and Daniel will go into the details on how this actually plays out and what are the some context around the behind the models. But before going into the details here, I'll talk a little about the latest trends in the market and what we see. So what we have seen over the years is that there's a dramatic increase in the transfer fees, which means that clubs are focusing more and more on the transactions. And we can see that they're investing a lot in people around this, hiring more people, of course, with the aim of minimizing the risk that are associated to these transfer values. But despite of that, we still see that there's still transfer may be made that are not really successful. And when we go back and ask the clubs and the sport directors, the scouts, and so on about how they evaluate it and what are the conclusion of these evaluations, they usually say that what they get right is the kind of the description and the observation of the qualities of the individual skill set. So the way the physical aspect, the technical aspect, and the passing skills and these very tangible, observable things that they can do in the match, they usually get what they expect. What they are struggling with is identifying aspects of the strength in the league where he's playing. What is the strength level? What is the adversity level? But also what is the style of the team and how is that difference there? And this is what we're going to focus on today. Identifying the context around the player. As you can see here, we have worked on this for the last 3 years now, describing the context and having all these models here. There's a lot, and there's no shortcuts here. You simply need to add. The more context you can add to your to describe your environment, the better your prediction is going to be. So this is what we're going to talk about today. So the different points here will be those 5 as you see here. The first part is identification of the skill set, what is specially needed by the club. But very important here is that we tie it to what is the style in which the team is playing. So what is it the player needs to fit into, as you can see in point 2 here. Now, once you have identified these requirements from the club side, we then look at, okay, what is the players on the target list, where they're coming from, what is the gap between the team you have where you're playing, as well as the team where the player is coming from, to see the gap there at the level of adaptation. And then once you have that identified, we could then look at how that would impact the performance of the players. And then following that, of course, interesting to understand how that will impact the overall team performance. Now, the last point we haven't tackled yet, but we have all the ingredients to solve these issues, and we're going to talk a little about some considerations we have within that area there. But just let's get started with the first point. So the first point is around the role discovery, identifying the role and the need within the team. You probably have seen this framework here previously, some of you, as we have presented it on the Pro Forum a year ago. So I'll not go in detail here, and Joe will show you some examples of this. I'll just mention that some of the research that we did prior to this was we went out to talk with a lot of clubs, over 50 around the world. And the 2 points that were highlighted as the most important ones, that they needed a more nuanced way of segmenting players than the position, the spatial position segmentation that they're currently using, because there was more to it than that. The segmentation based on their qualities and the skill set and the characteristics is needed. The second point that they highlighted was that most sport directors and scouts do not use numbers to describe players. They use similarity to other players. So what is really important here is that we link players together in terms of similarities, and we can always find out how players are similar, and we can use players as search points and not necessarily just filtering based on numbers, but we use the departure point as a player as a search point, and then look at the similarities from that. Now, if we look at the items that needs to be considered once you want to identify the need of the players, one way that is specific to our approach here is our departure point is the team in which that you're representing. We want to understand what is the style of the team. We don't want to look at we want to take an overall list of a lot of KPIs and just filter down and then find the ones that are on the top. We want to see, okay, what is it that the player needs to fit into? And then from there on, of course, that sparks out a lot of other needs. Then we need to make sure that we have described the playing style. Is there a playing philosophy? Is it explicitly described in the club? Are the scouts aware of this? And can it be measured? So we all know that if you have to observe 22 players in the game and look at also the style of both teams as well as strength, it can be extremely complex. So having this described on a technical way and be measured just makes it much more efficient. Once you've done that, of course, you start considering also what are the specific roles that are prevailed in that style. And then, of course, also is there some roles that are more important. So, for example, if we know that in certain styles, certain roles would be creating more danger than others. If you're going out on the market and spend money, you want to make sure that you spend your money on the roles that are really important to your playing style. So that's another aspect that the clubs would consider here. Now, once that has been identified, the next part would be to look at what is the gap from the players that has been identified as transfer targets. What is the gap between where they're playing currently and where they're going to? We do that by looking at the team's similarity profile, both offensively and defensively. By identifying the gap, of course, the idea is that the bigger the gap, the more the player has to adapt, the more risk there will be. So that is extremely important that we can get an idea of that. But it's even more important that we also understand on which parameters these gaps are. So we basically, through this similarity profile, we can understand where are the biggest gap. And then we also work with importance filters because certain KPIs or certain style indicators would be more important for some teams than others. And having these importance filters, we can allow us to identify exactly if this is something that is really hitting on some of the points that is important to the specific club. Now, once this has been identified, we can then look at other players and from the similar club moving to the same league and look at how they're successfully doing this transfer, just in order to identify the risk level, and identify what is the level of adaptation. But focusing on the style aspect, the other aspect is the strength level of the league and the team, and we have also developed a way of identifying the strengths across leagues. So understanding what is the expected adversity in that league and what is the level of the team where he's playing, if it's a top club or if it's a bottom club, or where are they in terms of strength. But also if there is a dominant style in that league. And we know also that sometimes a certain role would prevail in a league. Certain role would be predominant in the league because they play in that specific style. That will allow us to understand better what is the league and the environment in which the player evolves. Now, once these 3 points there has been identified, we will then be able to give a good prediction because we have a good description of the context and then simulating these transfers and with its expected performance. Now, without further ado, I will then pass this word on to Joe, who will explain a little more about how we implement this.
We're going to lead up to us looking at a walkthrough of a recruitment example using some of the tools that we've got in our Bag Stats Perform, and take you briefly through some of the methods that we've got to describe player style, team and league quality, and then finally bringing it all together by simulating transfer using our transfer portal model. So yeah, and what I've already mentioned about our role discovery platform, which is a way for us to assess a player's role on the pitch by going beyond the simple traditional positional labels like centre back, full back, and centre forward. So we know that players in the same position can possess really different qualities and be asked to do very different things for the team. So think Trent Alexander-Arnold versus Matty Cash at right back side. And we might therefore want to evaluate these players by a different set of KPIs. So role discovery uses metrics from several different stats perform models that I won't go too heavy into the detail of the model itself because it's already been covered at the Opta Pro Forum last year. And there's a link to a full presentation that you can watch on it there, but I just kind of whistle-stop tour through the metrics that go into it. So these metrics include possession value, or PV, which is a measure of the pass reward, also known as attacking threat with some companies. Basically models the probability of the team scoring in the next 10 seconds and how much that probability increases or decreases due to each player action. We've got expected pass completion, or XP, which is a measure of pass risk, or the likelihood of an attempted pass being completed. And from this, we can derive things like passes completed above expected, which is a measure of how much better or worse a player is at actually completing the passes that they attempt versus their expectation. We've got movement chains, which are sequences of 3 or more team passes. And these can show us the kind of motifs of players involved in. So these are things like, are the player the initiator of a 1-2? Are they the middleman in a 1-2-3? Things like this. And in which areas of the pitch that these sequences tend to pass through. We've got our playing style framework. So this quantitatively describes the style of each individual team possession. So for example, we can see a counter-attack style here, which depends on the vertical distance and the speed of movement that a team makes after they regain the ball. So we can use 8 playing styles like this counter-attack, and other things like maintenance, sustained threat, direct play. And we use these to describe players in terms of the types of team possessions that they find themselves in. And finally, we use heat maps as spatial descriptors of passes made and passes received to show us where players operate on the pitch. So more specifically, we use a dimensionality reduction method called non-negative matrix factorization. And this decomposes player heat maps into a set of explanatory factors. So we might see here someone like Matty Cash, who has a high weight for this factor 0 in terms of his pass origin. So this shows that he makes a lot of passes, say, in a deeper defensive area of the right flank. And his pass destination factor, which is 1, might have a high weight to show that he makes those passes further up the pitch, but still on the right-hand side. And we could compare him to someone like Alexander-Arnold and see that his pass origin main factor is much higher up the pitch, so it's in the opposition half. And his pass destination main factor is basically deliveries into the box. It includes a lot more. So we take over 70 different features and we use a Gaussian mixture model, or a GMM, to learn 25 unique player roles. And it can be kind of difficult with this many features to be able to visualize them properly, but we can reduce the dimensionality into a 2D representation. So we use principal component analysis, or PCA here. The example I guess we'll look at in the next couple of slides will be Firmino versus Lewandowski, who are both traditionally labeled as centre forwards despite doing really different things for the team. So we can see this group of forwards labeled in red and all players as the other point in black. And see there's like a big group here with not much distinction between them. But if we apply our role discovery labeling, we can see that Firmino is labeled as an attacking inside threat, the point in yellow, and Lewandowski as an advanced forward, the point in red. And we have qualitative and quantitative descriptions of all of these roles. So for instance, attacking inside threats like Firmino, they tend to operate in high central areas, they move the ball out wide, and they contribute to a lot of counterattacks. And then advanced forwards like Lewandowski, they tend to progress the ball higher up the pitch and into the penalty area, and they take a high volume of shots from inside the box and also have a lot of headers. So using these newly assigned roles, we can more meaningfully compare potential targets with similar players in specific KPIs of interest to these roles. So for example here, we might want to look at expected pass completion rate, or XP, where the grey points are all forwards. The points in orange are forwards, or players with the role of the player in red. So say Firmino in this the top example. And we can see, so players on the right-hand side of this distribution would be attempting simpler passes with higher XP, and players to the left, harder passes with lower expected completion values. And we can see that, say, Firmino is 99th percentile of all forwards and 97th percentile for just his role, so he's very high in both. With someone like Lewandowski, who's pretty high across all forwards, so 84th percentile, he's in this top half squarely. That if we look just at his role, he drops down to the 65th percentile, so actually attempts more difficult passes compared to other players with his role. And we could, build up a passing profile if we wanted. We could look at any number of things, but here, possession values of attacking threat, and we can see that Firmino is maybe just about a top half forward, so 67th percentile in terms of PV, but he drops within his role to the bottom half forward. He's not having the most attacking threat in terms of his role. But someone like Lewandowski comes out from being very good already at the 92nd percentile. So just looking within his role of advance forward, he's literally like one of the best, one or two at doing what he does in terms of rating attacking value. So in the remainder of mine and Danny's slides, we're going to drill down into a more specific recruitment case using a real world example. So we've got Ren. We've had some really good recruitment in recent years, but especially on the right wing. So they had Ismail Assar, who they brought in a few years ago from Metz for 50 million and sold him for nearly double that a couple of years later to Watford. They replaced Sarr with Rafinha, who they got in from Sporting. He left the Leeds a year later in weird circumstances. They didn't make much profit, but they immediately turned to Jeremy Doku, who they got in from Anderlecht for £23 million last summer. And he's already being touted with big money moves to clubs like Liverpool and Spurs. So using our Edge recruitment platform, we can quickly drill down into the high-level player similarities like we've seen with the PCA for Firmino versus Lewandowski. So we've got Rafinha and Doku here. And we can really easily filter by specific roles with this. So here we've got attacking wide dribbler and attacking wide threat, which are two roles which are highly relevant to wingers. We can filter by competitions. So we've got 10 big European leagues here. And we can filter by any number of KPIs that we want with these sliders here. So for this example here, we've chosen to have a slightly higher amount of attacking threat that we generated, where we can do this with playing styles or general things, just like canonical position. Maybe we do actually want to look at wingers, age, height, any kind of things like this. So Doku and Rafinha don't look particularly similar at this high level, but we can explore all of the individual underlying features and compare them like we did for the Firmino Lewandowski example. And just a couple that we can easily do with our Edge platform. We can look into playing styles. So say for Rafinha here, who's represented by these points in blue. We can compare him to the average player in his role of attacking wide dribbler, which is represented by the points in grey. And we can see, say, for crossing here on the far right, that Rafinha crosses a lot less than the average player in his role. If you're going to compare with Jeremy Doku, who's in a similar but distinct role of attacking wide threat, we can see where Doku is the point in blue. The average player with attacking wide threat role is in grey. And Rafinha is set as our benchmark player here with this triangle. So it's the same points as here carried over. We can see that Doku crosses a lot more than Rafinha, and also a lot more than the average player with his attacking wide threat role. And yeah, we could do this for any number of KPIs that we're interested in. So we can jump from the player level to the team level in order next to be able to describe how similar other teams are stylistically to our own team, and in which KPIs specifically that they are most similar. So doing this, we could investigate the fit of potential recruits that we've already shortlisted, or even generate a new shortlist of players, depending on which team we find as being similar to our own. So our Edge platform, again, can quickly show you things like these playing styles radars for each team. So we could quickly get an overview of Ren that makes them tick. We can see for the playing styles, say, that Ren have a lot of fast tempo sequences, so 67% more sequences with the playing style of fast tempo compared to the average player. Sorry, the average team represented by this dotted line. and say they have 23% fewer counter-attack sequences compared to the average team. And we can look at this over any number of features that we've got. So here we just got a swarm plot where you can see Ren represented by the badge, other teams from the top 10 or from 10 European leagues represented by these points in blue. And we've got a normalized score here of between 0 and 1 for each metric. And I've just selected a bunch of metrics that might be similar to wingers or to these roles specifically that we want, wide attacking threat and attacking wide dribbler. And so we could see, like with the radar plot, that Ren's counter-attacking is relatively low compared to other teams. Their crossing is relatively high. But we can also see other things like Ren attempts relatively simple passes in the final third, so their XP values are high. They engage in a smaller number of 1-2s in terms of the passing chains. Using over 100 features like these that we've got, we can generate a quantitative similarity score in order to more analytically define a set of similar teams. So we use Mahalanobis distance, which is a distance metric that kind of better accounts for high dimensionality compared to other metrics like Euclidean distance. What's really cool about this one is that we can personalize these similarity scores based on a set of custom weightings. So we could either individually group or individually weight each of our 100 features. But what we've done is define 10 groups of features. So here we've got, say, playing style. So all our 8 playing style features have been condensed into one group of playing style. And we can attach a weight between 0 and 1 here. So for this example, kind of thinking of Doku or a winger that we might bring in, we've assigned a relatively high weight to playing styles and to shot types, a little bit of a lower weight to passing quality, motifs and chains that we're involved in, and a much lower weight to defensive actions. And we can also build an out of possession similarity profile. So these top ones are basically on the ball actions, and the bottom one we can use using opposition allowed features. So these are things that a player allows their opponent to do when they're on the pitch. And that's things like how are their opponent allowed to operate in terms of the playing style, what kind of shot quality and from which areas of the pitch do they shoot from, how does their passing look and where do they operate, where are they defending, things like that. And we put a pretty low rating on this here because we're more interested in possession features maybe for someone like Doku. And so using this custom weighting of the stylus that we just shown, this would be our 8 most similar teams stylistically to Ren across the 10 European leagues that we've chosen. So we've got Chelsea, Braga and Atletico as the top 3 teams with about 71% similarity. And this would be on a scale of 0 to 100%, where Ren are pretty much going to be the only team that have 100% similarity to themselves, who have excluded there. It's cool that we can investigate this across any of the individual feature groups that we've got, regardless of the importance that we've assigned to them. So yeah, this is our condensed version with all weightings. But we could maybe just drill down into these same 8 teams in terms of their playing style similarity, and then see a team like Marseille, who is 8th highest, comes up as most similar, and someone like Dortmund, who's 4th highest, comes up as least similar on this top 8. We could look at this for their out of possession profiles if we want as well, and then see, say, Braga come up as really similar in terms of their opposition allowed features, and a team like Chelsea come up with pretty dissimilar. And then finally, we can visually compare this for 2 specific teams we want. So looking at the playing styles radar that are shown for Ren already, maybe we've selected Anderlecht and I'll do, for example. We could eyeball these easily enough to be able to see, say, the fast tempo that we found before, that Anderlecht also have a 30% higher number of fast tempo sequences, also a lower number of counter-attack sequences. But kind of more usefully, we can compare these directly, overlay them on top of each other with a kind of custom template that we've got here. So this would be for a set of features similar to what I showed in the swarm plot that we might find relevant for wingers. And say Ren would be the black and fold boxes here, and Ren the red boxes. And we can see the things like that Anderlecht have a lot less crossing than Ren, but see more interesting things like the passing profile of Anderlecht and Ren, pretty similar in the final third. So they both have similarly lowish average amounts of attacking threat generated, relatively easy passes that they play in the final third, and things like their 1-2 usage is kind of similar. So yeah, that's a nice way to more kind of analytically compare these. So far in the bit that I've looked at, we've described players and teams mainly stylistically. But what about in terms of the quality, which is arguably the more important question in terms of recruitment? So I'll leave it to Danny to take you through the next little bit of that.
So the idea here is that Joe has talked a lot about the stylistic elements of players and teams, but we also want to now, if we predict how a player is going to perform at a new team, understand not just the style of fit and how well a player will fit, but the actual ability change in any given transfer. So to do this, we wanted a single ability rating score for any team pretty much across the entire world. So we created an internal system called our version of Power Rankings, the Stats Perform Power Rankings, which is a global soccer rating system. So this system is run on games since 1990, so we can go back all the way back to 1990. We can run it over 190 countries, over 400 leagues, and it's getting up towards around 3 million games in total now. And on any given day across this period in any of these teams and leagues, we can assign a single ability score between 0 and 100, where on a particular day, the best team in the world is ranked 100 and the worst team is ranked 0. So here's an example from last week. Man United coming in at 10th best team in the world, probably won't be there this week, but you can see like this is the top 10 teams globally according to this system, where Bayern Munich being 100 means that they are the best team in the world on this particular day, but it doesn't mean they're the best team in history. Any given day in the past 20 odd years, there'll be a team with 100 ranking score. So this wide net provides us with a lot of data to train our models internally across any number of leagues that we can really get event data for in this case. And we're going to use this not just internally to train models, but hopefully as a product in itself. And this power ranking system is quite involved because it's trying to cover the entire world here. We're trying to cover, thousands and thousands of teams. I think it goes up to, over the 20 years or so it's been running, as about, it's like 20,000 teams, I think. And we wanted to update this and let the sort of changing world footballing picture be updated quickly and efficiently through this method, so that when certain countries and certain leagues become better than they were a few years ago, that we can accurately represent this. And to do this, we use a hierarchical system where we have 4 layers to the hierarchy. We have at the bottom, we have the within league team rating score. We have a league rating score, a country, and a continent score. And each one of these scores is basically an ELO rating, which is a simple score which will assign an ability score to a team or a league or a country or a continent, and it'll give us an impression of how we expect them to perform in a match. And then based on the result of a match, just the results, just the final score, we update those scores accordingly. So one example is to say, okay, let's say we have a Club World Cup game, and we've got, for argument's sake, Manchester City are playing, I think for today it'd be relevant to say Fluminense. And we want to see how that is going to not just impact the team rating abilities, but we want this game to also adjust, in this case, the highest level of our hierarchy, the continent ratings. So the team score for Man City would be a sum of each of the 4 levels of the hierarchy. We see how good they are within their league, how good the league is, how good the country is, and how good the continent is. We sum those 4 values together to give them their ability rating. That's their final power ranking score. And we will then pit that against Fluminense, and we see who wins the game. And let's say Fluminense win, even though we expected them to lose based on the ability score we had for them. Then it won't just be the team scores that we update. We will update the European and South American values. And that would mean that Europe would see a little hit, and that every team in Europe, therefore, since they're a sum of all the values in the hierarchy, would see a reduction in their actual ability score. So this way, you're almost thinking of like Manchester City representing Europe. And we'll then see these abilities of teams and continents and countries propagate more quickly through the system, so that hopefully we can have an estimate of ability of comparing, say, a third tier team in Ecuador to a 5th tier team in Spain. So before we actually look in some examples that go over time for specific teams, I want to go back to what Joe was talking about before, and with these REN examples. And for the rest of this talk, we're going to look at how we could have predicted how Jeremy Doku would perform when he moved from Anderlecht to REN back in October of 2020. And this is using our transfer portal model, which is going to try and predict performance based on ability and stylistic metrics. So the first part is just what I've just talked about, these power rankings. We're going to make this transfer. We are in the position of REN. How do Anderlecht compare to us? We need this information to understand how he might perform at our club. And if we look back to 2015 and their relative power ranking scores, you can see that Anderlecht in purple were ranked higher up until around mid-2018 than REN. But since then, it's been REN in the ascendancy. And as of the transfer date here by this vertical line, you can see that Rennes are considered a better team than Anderlecht quite significantly. But this only tells really one part of the story. We also need to know what is the relative league ability of these two teams. And we can have a look here at the distribution of teams within both of these two leagues at the time of the transfer. And on the left, we have the Belgian Jupiter Pro League, and on the right, the French Ligue 1. And you can see that Rennes are, as we mentioned, rated higher than Anderlecht, but they're both pretty good teams for that league. But you can see the distribution shows that according to our model, the French Ligue 1 is a stronger league pretty much overall when compared to the Belgian Jupiter Pro League. And we need all of this information on not just the team we're transferring to and from, but also this distribution of team quality within the leagues if we want to predict how we expect Doku to perform at Rennes. But now we need to bring everything together. We need to bring together the ideas of style and substance to predict future performance. And we're going to do this in our transfer portal model. And the idea of this model is we're going to look at the current team. In this case, this will be Anderlecht for Doku. And we're going to look at the team and league power rankings and to get our idea of relative ability of these teams and leagues. And then we're going to bring in a lot of the player metrics, which Joe was talking about earlier. These are some of these will be ability and some of these will be a bit more stylistic. These will be per 90-minute metrics, for example, shots per 90, goals per 90, tackles per 90, that sort of thing. And we then bring in team and team positional metrics. So how do Anderlecht play? What is the style of Anderlecht? How do they utilize their wide players? And we do this for both the target team, the current team, and the target team, which in this case is Rennes. And our goal is to then move this player into the target team and predict how their features are going to change, how their performances are going to change when they move from Anderlecht to Rennes. So to do this, we are using a multi-head neural network model, which predicts 19 separate metrics, and these are aggregated per 90 metrics. So what I was talking about before, things like shots per 90, XG per 90, XA per 90. It could be things like passes in the final third per 90 minutes. And we fit a single multi-head model that predicted all 19 of these metrics simultaneously because it allowed us to share a lot of information when predicting these targets rather than fitting 19 separate models. And the flexibility when using products such as TensorFlow allows us to really experiment with different model structures, and we got by far our best predictive accuracy when using this approach. We also can predict not just how players are going to perform at the target team, but also how are they going to perform at the current team if they stay put. We might have a young player come into the squad for the last few games of the season and do really well, but do we think that that player can maintain that in the following seasons? That's also an important question. So we're not just going to train and predict on transfers, but also cases where players have stayed put in the same club and seen how their future performances have related to their previous performances. So to have a look at some of the outputs, I'm going to run through some of the internal plots that me and Joe have used to look into the model. And so some of them are a bit scrappy because they are definitely very internal visuals that we've created. And there's a lot going on, so I'll try and step you through what we're looking at here. But here we're looking at Doku moving to Rennes. We're simulating the transfer as if we were the position of Rennes wanted to sign him back just before he signed in September of 2020. And the very top here, we have this metric is basically the amount of passes in the final third of the pitch per 90. This is one of our 19 targets. And we're just going to concentrate on this top part here now. And what we have in gray is this value 17.23. This is our prediction if Doku was to stay at Rennes for the 2020 season of his passes per 90 in the opposition third. This 15.68 is our prediction if he moves to Rennes. So we're predicting a slight reduction in passes in the final third when he moves to Rennes versus staying at Anderlecht. And we have this lollipop plot here showing the percentage change. So it gives us an idea, because each of these prediction targets is on a different scale. It gives us an idea of the relative change, which in this case, for most of these targets, is between 5 and 10% reduction. The only one we see an increase in is this XG per 90. Now, there's hundreds of features and it's very complex. There's a lot of stuff going into the models trying to understand styles and quality. But in this case, some of the most important features that we could look at to try and think why might this happen would simply be these target features that we're trying to predict for the player, but at a team level, the actual features that go into the model at a team level. So what I mean by that here at the very top is instead of looking at how we predicted passes in the final third for Doku, what are the actual passes in the final third for Rennes and Anderlecht, and what's the change for wingers at these teams prior to the point of the transfer? So what we're saying here is that the average winger at Anderlecht has around 17 passes per 90, and the average winger at Rennes has around 14.7. So actually, we're predicting him to come in higher than the average for the team. But what you can see is that there is a sort of a trend here of a lot of these metrics that we're looking to predict on in this particular example are reduced when you move to Ren. They part from XG per 90, which is quite a drastic increase of 25%. So at the point of this transfer, Ren relied far more on their wingers than Anderlecht did to actually create goal scoring opportunities. And that is one of the reasons, one of the many reasons that we see this slight increase here in XG, even though the others were decreased in this prediction. Another thing we like to look at is, we've already covered, so don't need to spend much time on it. It was just the relative change in ability of the teams and the leagues. This is a pre-scaled version of our power ranking, so it's on a completely different scale, but this bar here, these parallel bars, are showing us that the Belgian Jupiter Pro League is slightly weaker than the French league according to our model, and Anderlecht is slightly weaker than Rennes. But the fact is, you're moving to a better team, he's also moving to a stronger league, so all of this needs to be accounted for in predicting his performance in this move. And finally, maybe the most important part of this in many ways is trying to understand, if they were to use this and predict how Doku is going to perform, some element of uncertainty that we might have, not necessarily in our model predictions, but in the actual features that feed into the model. So we have quite a simple traffic light system, which we show here, which is a terrible name of knowledge score, which I don't know what we were thinking assigning it that, but internally we've called it the knowledge score. There's 3 ratings that are assigned, basically a green, amber, red value. Green meaning good and red meaning bad in this case. So green here is showing us that we have plenty of data on Doku, Anderlecht and Rennes, and not just for the team, but for the position we're trying to predict on here in the wing. And this tells us that the features we have that will feed the model predictions are as accurate as we're going to get. And this is important because there's a lot of predictions that we'll want to make where we just maybe don't have the relevant information for that prediction, and we're going to put a warning sign up here. And I'll give an example of this in a few slides' time. So this is all well and good. We've kind of shown what we can predict, but there's no context here. You know, is this good? Is this bad? You might be inclined to say it looks like a terrible move because all the predictions are reduced, but there's absolutely no context to whether these values are good in the transfer. So to do this, we use swarm plots. And initially, I'm going to show you what our values would be predicting all players in the Belgian Jupiter Pro League, all wingers in the Belgian Jupiter Pro League, simulated at their current club for the 2020 season. And this is for XA in the top plot, and this is the number of take-ons per 90 on the bottom plot. These are just 2 of our metrics. And the expected assist here, each grey dot is a player in the Belgian Jupiter Pro League, simulated in their current club. And the orange ones are the Anderlecht wingers, simulated at Anderlecht. And in red, we have Doku. So what you can see here is that we're predicting Doku, this P96 is telling us he's the 96th percentile. We predict if he stays at Anderlecht that he's going to be one of the best players in the league in terms of creating chances, in terms of his XA. And in fact, he's the best in the league for take-ons per 90. And now if we make this transfer to Rennes, we're going to have the same plots to give this context, but now in Ligue 1. So now all of these grey dots are the players in Ligue 1, simulated at their current club, all their wingers. And now we have the Rennes players in orange, and Doku now simulated in red at Rennes. So what we're showing here is that at Rennes, we simulate him to be about average for the team. The actual raw value is reduced very slightly from, I think, 0.19 XA per 90 to about 0.18 XA per 90. So it's a very minor change. And he's staying very high in terms of percentile value here of 81st percentile. And in fact, the take-on is much less of a team metric, it's more of an individual metric. And you see much less change in a metric, in a target like this. So he's maintained a very similar value and stayed very high in terms of percentile rank. So the actual value in his first season at Rennes, he got 0.18 XA per game, which is very similar to our prediction. So that's great. In this case, we've managed to predict accurately that actually, it was a step to a tougher league, but the fact he was going to a better team and there was a relatively decent team fit there, that he is going to perform at a very high standard, and it's a very good transfer, at least in terms of these metrics. But it's not always this simple. So we're going to show one more example where it was a much more difficult prediction. So in this case, we're going to look at another Rennes player. So as Doku came in, Rafinha came out, and he went out to Leeds. And first of all, we're going to show the predictions on the left here, just as we did before at the current club. So this is predicting Rafinha if he stays at Rennes for the 2020 season. And this is XG, and this is our XA predictions. And in both cases, we're ranking him very, very, very high in French Ligue 1. But we're moving him to Leeds, and this is where we have to be very careful with our predictions, because Leeds have just been promoted from the Championship to the Premier League. So we don't just want to predict how a player is going to play at a new team, but we also need to predict how that team is going to play. So we need to predict how Leeds are going to perform and how they're going to use their wingers in the Premier League. And we do this, basically, we call our models feature adjustment models. We have a lot of models that will help us create our features. They almost create like priors, initial values for teams and players that will be updated as we collect more and more information. And in this case with Leeds, we're going to predict their Premier League performance based on how they played and their performance in the Championship, the league before, the season before, but also how previous teams moving from lower to higher tiers with a similar power ranking change will actually change their style and how they will perform. So we have to do that to create our team features that will feed into the model and be used to predict how Rafinha is going to play. So if we actually look at those predictions of him at Leeds in the Premier League at the start of the season, based on pretty much no information on how Leeds are playing in the Premier League at this point, we'll see that his XG is, both are dropped quite significantly, but the XG is considered pretty decent still. But his XA per 90 in this case is dropped to about average in the league, which is still okay for a newly promoted team. But we've dropped the prediction from about 0.17 to about 0.13, which is quite a drastic change. And in actuality, his real value for the 2020 season was way up. It was like 0.18 or something. He was right at the top end here. Should have been the like high 90 percentile. So we really underestimated his performance in the Premier League. And this wasn't necessarily the model misunderstanding how he'd fit in the team. And this was, you know, the struggle that we have with this big red bar that we're trying to convey if someone was to make this prediction, is that there is uncertainty on how Leeds are going to play. And in our case, we did underestimate the performance of Leeds when they moved to the Premier League. We had them as much more of a relegation candidate, and that's what we predicted when we moved Rafinha to them in this case. In actual, of course, in reality, they, you know, performed much better than we expected, and we were off on this prediction. But that's pretty much it in terms of our transfer portal examples. But we've got a few areas that we want to take it. Or we are taking it. So currently we're integrating player role into transfer portal. So those of you who are listening to Joe's part will have noticed that the idea of role, we discussed that a lot, and these ideas of not necessarily using position labels, but position roles. And this wasn't referenced in my part of the talk. And that is, even though we're using a lot of the underlying models that Joe talked about, we haven't actually integrated these labels of role rather than position into the model as of now. But that is an ongoing project, so that we can not just say we're looking at wingers, you know, we're looking at attacking wide threats, say, for example, rather than just looking at wingers. And I think the bigger project really, and maybe more important one moving forward, is how we change, not just predicting, how we change the project from not just predicting how a player will perform at a new team, but how is that team going to perform with the new player? How are they going to impact on all the other players in the team and interact with all of the players? Because I think a good example is, if, you know, I hate to harp on Man United, but watching Ronaldo this weekend, and you see the way that he plays in our transfer portal model, if we moved him to Manchester United this summer, you'd see a lot of his attacking metrics looking very positive. And that is true. But we also need to understand how a player like Ronaldo would fit in to the style of the team and interact with other players, and therefore impact the other players on the team and how the team actually performs, rather than just how the team impacts their personal metrics. And to do this, we're looking at a graph convolutional neural network approach, where we would basically have all players on the pitch as ed features and look at how they interact with the target player that we're looking to move. And we've done some work on this in the past in our team. So I highly recommend, if you're interested in this sort of approach, there's a link here at the bottom to a talk done earlier this year by Paul, Michael, and Thomas, who used a graph convolutional neural network approach to create an expected threat model on tracking data. So that's everything, at least from myself and Joe. Let's see if Jens is back.
Yeah, I'm coming back from the dead here.
Okay, to finish up the final. I don't know if you want to do this or go back to the start, Jens, but.
No, it's all right. It's all right. You know, just summarizing it. And so, yeah, we saw today that, you know, we managed to by looking at the roles, we could see how we could find roles that fit a certain stylistic way of playing for a team. And we also looked at team similarity and trying to understand the gap there is between where the player is going and where he's currently playing. You know, the bigger the gap is, the more risk there is involved in the transfer. And this is what we want to understand and most likely to minimize. And the same goes also for the power ranking. We saw how we could look at the different strengths of the leagues and the team. And then again here, assess what is the jump the player needs to make and what is the risk involved in that. And then finally, putting all this together would allow us to do a quality prediction. Now, there's a lot of groundwork that needs to be done here. And I think this is a really good example of how you know, the AI models allow us to access some rather very complex concepts. But, you know, once we do all the groundwork and get the output out here, we get something really digestible and easy to understand at the end. Yeah, I think this is a good example of that. So I think that's about it. I don't know if there's any question.
I don't think there are at the moment, actually, Jens. Good to have you back. Well done, guys, for picking that up. That was very good after a tricky start. Yeah, no, we've had Connor Malone says this is very informative, really interesting to see what you're working on. So nice bit of feedback there. And it built very well on what Paul Power presented last year, and Ben McCreel actually the year before that. So there's a nice bit of continuity there. I don't know, was there anything else you wanted to add at all, Jens, do you think, or?
No, so basically it was more about the why to begin with, why are this important? As we've done a lot of research in the market, understanding, what is important for the teams, and basically the role and the segmentation based on roles is extremely important. And we can see that. Another thing is also what we understood is that it's rarely that the teams or the scouts and the sport directors describe players with numbers. They usually use similarity to other players. And that's why we basically build a structure where all players are linked together in terms of similarity. And we understand on what areas they're similar and not similar, because that seems to be the preferred way for scouts and sport directors to navigate. It allows us to use players as search points, basically. Yeah. So yeah, that's basically the groundwork we did, the reasons why we started out with this role model.
Yeah, no, that's excellent. Well, thank you, guys.